So, hello dear students. Today we will continue our lecture of problem solution of UT1 paper. And today we will continue from section B. In last classes, we had solved up to section A. Today we will continue from section B. Question number 4, first part, as you can see on the screen. Observe the electric circuit above and answer the questions that follow. Observe the electric circuit consisting of a cell of EMF. How much EMF is given? 6 volt is given. EMF is 6 volt. A rheostat and ammeter and a voltmeter is connected across the cell. Here ammeter is also connected. And when the rheostat is adjusted to increase the current in the circuit, with the help of rheostat, we are increasing the current in the circuit. Explain how the voltmeter reading changes and why. So here students, we have to explain how the reading of voltmeter is changing, and we have to give reasons why the reading of voltmeter is changing. So this is in work mark. So students, the explanation will be also very simple. It is not a very tricky problem. Simply formula based. As we all know, terminal voltage is given by V is equal to E minus IR, where E is what? EMF voltage, I is current, and small r is internal resistance. So students, if we will increase current, then what will happen? This is in negative sign. Na? If it will increase, then what will happen? This terminal voltage will decrease. So students, you have to just write this formula and explain. So this is the solution of first one. Now next. Next is, in one setting, the voltmeter reading reads 4.5 volt, and the current in the circuit is how much? 0.5 ampere. We have to calculate the internal resistance of the cell in first part. And in second part, they are asking at what current will the terminal voltage drop to half of the EMF. So friends, we will continue for the solution of this problem. So here, as we all know that terminal voltage is given by V is equal to E minus I R. So here students, terminal voltage is how much? 4.5 volt. EMF voltage is given 6 volt minus current is given 0.5 ampere. You have to calculate internal resistance. So here student, 0.5 R, it will become 6 volt minus 4.5 volt. So here 0.5 ampere into small r, it will become 1.5 volt. Here students, so here your internal resistance will become how much? R is equal to 1.5 volt upon 0.5 ampere. So dear students, if you will divide this, your answer will come out to be 3.0 ohm. So internal resistance is 3.0 ohm. So this is the correct answer to the problem. So here students, in next part they are asking at what current will the terminal voltage drop to half of the EMF. So we have to calculate that current at which terminal voltage drop to half of the EMF. So students, we will proceed for the solution of this problem. So here we have to calculate current at which terminal voltage is half of the EMF. EMF voltage is 6 volt, 6 volt upon 2. So here it will be 3 volt. So now students, V is equal to E minus IR. So here terminal voltage is how much? Half of the EMF voltage, 3 volt, 6 volt minus, we have to calculate current. And what is the value of internal resistance? 3 ohm. So here, if you will simplify this, it will come I into 3 ohm, which is equal to 6 volt minus 3 volt. So current is equal to 3 volt upon 3 ohm it will be equal to how much? 1 amp. So your current is 1 amp. So this is the correct answer of this problem. And this way you have to, and we have solved this all these type of problems in the class. It's very simple. Now, sir, next, a technician is designing a heating element using two wires made of same material. The wires are made of same material, so their resistivity will be same. Wire X has length L and diameter D, while wire Y has length 2L and diameter 2D. Both are connected to the same voltage source. Based on the situation, answer the following. Compare the resistances of wire X and Y. So here we have to compare the resistance of wire X and Y. So here, see how to solve this problem. So for wire X, first we will calculate for wire X. So now students, for wire X, length L is given and diameter D is given. Length is L and diameter is small d. So what will be its area cross section? L into D. Is this clear? Now students, as we all know, resistance is directly proportional to L. Resistance is inversely proportional to area cross section. If you will combine, it will become L upon A. And here students, resistance is equal to rho into L by A, where rho is a constant, it is called resistivity. Students, if you will remove the sign of proportionality. So students, here for wire X, we have to calculate for wire X, what will be resistance? I'm denoting it by Rx, it will be rho, and L, area cross section is L into D. So here it is not, it will come rho upon D. Now, for wire Y, we will calculate. And if these both wires are na, they are made from same material, so their resistivity will be same. So for wire Y, Ry, it is equal to rho. Length is how much? 2L. For wire Y, length is 2L. And what will be area of cross section? Actually, for wire Y, length is 12 and diameter is 2D. So area of cross section will be how much? 4L into D. So here, friends, this. So here, resistance of wire Y, it will become rho into 2 to the 4, and then N and L will cancel out. So you will get here rho upon 2D. Is clear? So now, friends, we have to compare both resistances. So what we will do here? So here we will divide Rx upon Ry, Rx upon Ry, and it will be equal to how much? Rx is R upon D and Ry is R upon 2D. So here it will be 2D upon R. Rho and rho will cancel out, D and D. You will get 2. So here Rx is equal to, here friends, Rx is equal to twice of Ry. So here which is greater? Rx is greater by 2 times of R. And if you take the ratio Rx upon Ry, it will be equal to how much? 2 is to 1. So this is the correct solution of this problem. So now, students, you have to explain your reasoning. Uh, sorry, option B. Sorry, B problem. Then we will solve. No? We had solved A. So which wire will produce more heat when connected to the same voltage source? If we are connected both wire to the same voltage source, which will produce more heat? Your students will apply which law? We will apply Joule's law of heating. Here we will apply, students, Joule's law of heating. And what is Joule's law of heating? H is equal to heat energy is H is equal to I square RT. Here students, we don't know current, but we know that both wires are connected to the same voltage supply. So here we will replace current. So here, as we all know from Ohm's law, V is equal to IR. So I is equal to how much? V by R, and I square is equal to V square upon R square. Put it here. So H will be equal to how much? V square or R square into R into T. So here it will be how much? V square upon R into T. Is this clear? So now students, here, if you will see which has higher resistance, Rx has higher resistance as compared to Y. The resistance of wire X is greater as compared to resistance of wire Y. So here, resistance, the wire which will have low resistance, the heat energy will be more, because H is how much? V square upon R into T. Your heat is inversely proportional to resistance. So the one which will have low resistance, that wire will have more heat. So students, here the wire Y, it will consume more heat. What is the problem they are asking? Which will produce more heat? So here, which will produce more heat? So here, the wire Y will produce more heat because the wire Y has low resistance and heat is inversely proportional to resistance. That's why. This is the solution of this problem. Now, students, explain your reasoning using appropriate physical principle. So you have to just write about Joule's law of heating, and you have to tell heat is inversely proportional to resistance. So the wire which has low resistance, that will produce more heat. So this is the only solution of this. So now, student, third problem. This is also very simple. This will also, I think, we have done so much of times in the class also. So here, a household in Punjab uses an electric kettle rated 1.2 kilowatt, 240 volt for boiling water. The kettle is used for 2 hours daily. A student claims that higher power appliances always consume more electricity and are expensive to use. So here, next. So here, so this. So here, friends, use the information given, answer the following questions. Calculate the current drawn by the kettle when connected to a 240-volt supply. Is it? Here we will proceed for the solution. So you have to calculate current. So as all we know, power is equal to voltage into current. So current is equal to how much? Power upon voltage. And here, students, power is given 1.2 kilowatt. Voltage is how much? 200. 40 volt, I think. Yes, voltage is 240 volt. So here, students, convert kilowatt into watt. It will become 200 watt, 240 volt, 0, 0 will go by 0, 24 5 ja, 120. So here, students, you will get how much? 5 ampere. So this is the correct. Now next. Now, student, in the next problem, what they are asking, determine the resistance of the heating element. So this is also very simple. Resistance, what is the formula of resistance? We have solved most of the times in the class. R is equal to V square by P. What is voltage? 240 into 240. How much is power? Power is 1200 watt. So here, student, 0 will go by 0, 0 will go by 0. And 12 2 ja 24, 24 2 ja 48. 48 ohm is the correct answer. Now, friend, next, what they are asking? They are asking Yes. Estimate the monthly cost of using the kettle if electricity costs rupees 6 rupees per unit. So we have to calculate the monthly cost. So here we will proceed for the solution. So here students, first we will calculate electrical energy consumed if we have to calculate cost, and it will be in which unit, kilowatt hour, and it is equal to how much, voltage into current into time. And here student, voltage into current is what, power in kilowatt, into time in hour. And students, we have power given in kilowatt, 1.2 kilowatt. Time is given. Time is how much? 2 hours. So here, students, if you will calculate this, you will get how much? 1.2 into 2, it will be 2.4 kilowatt hour. Now, students, we have to calculate cost. So for cost, what we will do here? Cost is equal to, cost is given 6 rupees per unit, means 6 rupees per kilowatt. So here 2.4 kilowatt hour into 6 rupees per kilowatt hour into, for 30 days we have to calculate. So students, if you will calculate this, simplify this, 24 upon 10, 24 upon 10 into 6 into 30 rupees. Kilowatt hour and kilowatt hour will cancel out. So here students, you will get 144 into 30 by 10. Is this clear? So students, here, if you will calculate this, 10 3 ja 30 and 144 3 ja, it will be how much? 432 rupees. So this is the correct answer. Now, next is, do you agree with the student's claim? Justify your answer using calculation and reasoning. So students, what was the claim of student? That uh, higher appliances will consume more power. So student, the claim is not always correct. The claim is not always correct. Actually, congestion of electricity also depends on power rating, and duration of use. At what time we are using, friends. This is also not correct. So here, next. What is the next problem, friends? Next is, two bulbs are there, P and Q. They are connected to a 24-volt supply battery as shown in the circuit diagram. The power ratings are this: 100 watt, 50 volt, 25 watt, 50 volt. And the student observe the brightness of both bulbs and makes the following claims. Beautiful. What is the claim? Using appropriate calculations, determine the ratio of potential difference V1 is to V2 across the two bulbs. These are two bulbs and they are connected to the same voltage supply, that is 24 volt. We have to determine the ratio of potential difference V1 is to V2. So here we will proceed for the solution. Here, friends. So here, actually, if you will see the circuit diagram, yet two bulbs are connected in a series combination. So here, students, current will be same. This clear? Current will be same. And students, from Ohm's law, we know that V is equal to IR. For first bulb, I will take V1. Current is same, so it will be I, and resistance R1. For second bulb, current will be same because in the series combination, resistance will be R2. We have to calculate the ratio of V1 upon E2. So it will be R1 upon R2. So here, students, we have to calculate the resistance R1 and R2. So students, R1 is equal to V square upon power P1. So here, students, R1 is how much? So here, R1 will be, power is 100 watt, 50 volt for bulb A. So here will be how much? V square. V square is how much? 50 volt, 50 into 50 upon power is how much? It is 100 watt. Similarly, for bulb second, if you will calculate R2 is equal to V square by V2. So it is again 50 into 50 upon power is how much? 25. Take the ratio R1 upon R2. So here it will become R1 upon R2 50 into 50 upon 100 into 25 upon 50 into 50. So students, see how the calculation is simple. You will not find complex calculation in the board exam. And 25, 5 4 is 100. So how much you have got here? R1 upon R2. It is equal to 1 upon 4. And it is equal to 1 is to. This is the correct answer. Ratio of resistance R1, ratio of voltage is how much? So here we have got ratio of resistance 1 is to 4, and students, your ratio of voltage V1 upon V2, it is equal to how much? R1 upon R2. So the ratio of your potential difference will be equal to how much? 1 is to 4. This is the correct answer. 1 is to 4. Now, so next, the claim of student is bulb P gets fused. If bulb P gets fused, the current in the circuit will remain unchanged because the battery still provides voltage. Evaluate this statement as true or false and justify your answer using circuit reasoning. So this statement is false. Why? If one bulb will fuse, then what will happen? Your circuit will be open and there will be no current flowing in the circuit. So friends, what will happen? The circuit will change and the current in the circuit will become zero. There will be no current flowing in the circuit. So this is the correct solution of this problem. The circuit will be open and the current becomes zero. So here friends, this is fast. So next, what will be consequence if we connect fuse in the neutral wire? So students, if we will connect fuse in the neutral wire, then what will happen? When the fuse will blow blow away, then what will happen? The appliance still it will be connected with live wire. It will be in connection with live wire, and students, there will be still current in the circuit and you may feel electric shock. Now, from B part in the transmission of power, the voltage of power generated at the generating station is stepped up from 11 kilovolt to 130 kilovolt before it is transmitted. Why? So this I have told many of times in the class, so I'm not just see. So next, last problem of your UT1. The diagram below shows a magnetic needle. This is a magnetic needle. You can see it is kept just below the conductor AB, which is kept in north-south direction. See, this is north-south direction. In which direction does the needle deflect when the key is closed? So student, we have to tell in which direction does the needle deflect when the key is closed. So students, here, when you will close the key, then what will happen? Current will flow from positive terminal to the negative terminal. That is, current will flow from B to A. It is clear? That is from north to south. And yes, students, if you will apply a right hand thumb rule, your thumb, it should be in the direction of current. Then your curled fingers will give the direction of current. So here, students, in which direction this needle will deflect? It will deflect in the east direction. And students, I have taught this in detail in Oersted experiment. Why is the deflection produced? So students, you have to just write reason. A current carrying, when there is a current flowing in a wire, then a current carrying wire produces a magnetic field around. Right? this region you have to write. And next is what they're asking. They're asking what will be change in the deflection if the magnetic needle is just kept above the wire. So here, friends, if you will keep this needle just above the wire, then what will happen? The direction of deflection will change, and in this case, the deflection will be around base direction. In which direction the needle will deflect? If the direction of current is reversed. If you will reverse the direction of current, then the direction of deflection will also change. Now it will deflect along west when the needle is just kept below the current. So this was the solution of all the problems. If you have any query in the problem, you can contact me. And if you have liked my problem solving technique, then you can like, share, and subscribe my YouTube channel. That's all.